Hello everyone, I am Mohammed Salman representing the cohort crawl bench. This video focuses on the end course Capstone project module 2 where I tackle 25 coding problems. I will be addressing and explaining 5 of these coding problems out of the 25 coding problems. So I am going to explain my first coding problem. So this is the code where I have to find the error. So in this program, we are checking if a given number n is a power of 2. The mistake here is in the use of logical OR operator. The code will return true for any positive number because of n greater than 0, irrespective of whether it is a power of 2 or no. So it doesn't accurately determine if the number is power of 2. So in the solution which I have provided below, in this corrected code, I am using the logical operator AND instead of OR operator. This means both conditions must be true for the function to return true. The first condition n greater than 0 and ensure the number is positive, and second condition is n and bitwise operator n minus 1 is equal to 0. It checks if the number is power of 2 using a bitwise operator. If both conditions are satisfied, the function returns true. Otherwise, it returns false. Thus, this thing makes the function correctly determine if the number is a power of 2. So in the second problem, we are trying to find the bugs. So in this code snippet, we are trying to find the minimum number of parentheses that need to be added to make a given string as valid. The issue here is in the line if else open close increment. This logic incorrectly increment close even if there is no matching open parenthesis. It doesn't accurately count the minimum number of addition added to make the string valid. So here is solution. The code correctly find the minimum number of parentheses that need to be added to make the given string as valid. We are using more accurate approach. It increment open for each open parenthesis. And if a closing parenthesis is encountered, it checks if there is a matching open parenthesis. If so, it decrement open. Otherwise, it increment close. This way, the code accurately calculates the minimum number of the addition need for valid string. So in third problem, I'm going to explain, which is related to the logic building section. So first we define function maximum count. It takes an array of numbers as an input and count the number of positive and negative number in the array. Then it compares the counts and return the maximum of 2. So the function start with initializing the two variables. Let positive count assign the value 0, negative count, and we are assigning the value of 0. These will be used to keep track of the counts of positive and negative numbers in array. Then it goes through each number in the array using for of loop. Inside the loop, it checks if the current number is greater than 0. If it is, it means the number is positive. So it increments the positive count. If the number is not greater than 0, it checks if the number is less than 0. If it is, it means the number is negative. So it increments the negative count. After going all through numbers in the array, the function use max method to find the maximum count between the positive count and negative count. And finally, the function return the maximum count. In fourth problem, which is belong to analyzing traditional approach versus optimized approach. So this is traditional approach and this is optimized approach. So here a comparison between traditional approach and optimized approach. So I'm going to explain the advantage of the optimized approach over the traditional approach. First is simplicity. The optimized approach is more straightforward and easier to understand. It uses a well-known array method, slice, which clearly indicates the intention of creating chunks. Second, efficiency. The optimized approach is more memory efficient since it doesn't require the creation and management of temporary array. Like the traditional approach, it directly extracts chunks from the original array. Third, code conciseness. The optimized approach reduces the need for manual tracking of indices and memory arrays, resulting in more concise and readable code. Fourth advantage, maintain order. Both the traditional and optimized approach maintain the order of elements as they appear in the original array. And last one, ease of maintenance. The optimized approach is easier to maintain and less error prone due to its simplicity. So in my last coding problem, which is also belong to the analyzing traditional and optimized approach. So this here is a traditional approach and it is optimized approach. So uh, I'm going to explain the advantage of optimized approach over the traditional approach. So first is simplicity. The optimized approach is more straightforward and easier to understand. It uses a clear while loop termination condition based on the position of the left and right indices. Second, efficiency. The optimized approach performs the shuffling in the same number of iterations as the traditional approach, but with simplified code. Third, code conciseness. The optimized approach reduces the need for additional conditional checks and code complexity, resulting in a more concise and readable solution. Fourth, maintains order. Both the traditional and optimized approach maintain the relative order of element in the original array. And last advantage of the optimized approach, ease of maintenance. The optimized approach is easier to maintain and less error prone due to its simplicity. Thank you.